Hello everyone, today we'll be going over mathematics, paper 5-1, October-November 2021. This is probability and statistics first, and we have a time limit of 1 hour and 15 minutes. So let's get started. For the first question, two fair coins are thrown at the same time, and the random variable x is the number of throws of the two coins required to obtain two tails at the same time. So we're looking at two tails at the same time. That's going to be our event of success. All right, and we're denoting it with the random variable x. So we know that x is a geometric distribution because we're figuring out the probability that the two tails are obtained for the first time on the seventh row. So that's geometric distribution with the probability p. And the probability p, it will be the probability of success. And in this case, the probability of success is obtaining two tails at the same time. So we know that the probability of obtaining a tail when one coin is thrown, that's going to be 1 by 2. If this is the case for a fair coin. But we're talking about two coins, so that's just going to be 1 by 2 squared, which will be 1 by 4. So x will follow a geometric distribution with our parameter p equals to 1 by 4. Alright, now we need to figure out the probability that the two tails are obtained for the first time on the seventh row. So that's going to be seventh row, and we require success in this one, which means that there has to be 6 failures for the first 6 throws. So the required probability is going to be the probabilities of failures for the first 6 throws. So since we know that the probability of success is 1 by 4, the probability of failure is just going to be 1 minus 1 by 4, which will be 3 by 4. And that's going to be the failure for 6 times. So that's just 3 by 4 to the power 6. But we also have a success at the 7th row. So that's going to be the probability of success, which is 1 by 4. This gives us the total probability of 0.0445. That's the answer. Now we need to find the probability that it takes more than 9 throws to obtain two tails for the first time. This just means that within the first 9 throws, that's just going to be the failures. Because we need to obtain the two tails for the first time on the throws that are greater than 9, right? Which means that there has to be failures for the first 9 throws. So the required probability is just going to be that of the failures for the first 9 throws. And we already know that the probability of failure is going to be 3 by 4. So that's just 9 times power 9, which gives us the required probability of 0.0751. This concludes the first question. Let's move on to the second one. A summary of 40 values of x gives the following information. So we're given summation x minus k and summation x minus k squared, where k is a constant. Now, given that the mean of these 40 values of x is 34, so this is the mean value, we need to figure out the value of k. All right, so what we're given is that the mean value is going to be 34. So we're going to figure out the value for k with the help of this information. So that's summation x minus k equals to 520. So if we're talking about the summation of a variable, that's just going to be the summation sign. Now, if we're talking about a constant, which is the case for k, and if we're summing the values of constants, then the summation sign will actually change into the number of samples or the number of values. So that's going to be minus nk, where n is going to be the number of samples. And in this case, we know that the summary is of 40 values, so that's just going to be our number of samples, which is summation x minus 40k equals to 520. Now, if you just figure out the value for summation x, we can easily figure out the value for k. And in order to figure out this value, we're going to use the information for the mean value. All right, I'm just going to do it right here. So we know that mean is just summation x divided by the total number of samples, which in this case is going to be 40. This gives us the value of 34, which means that the summation x value is just going to be 34 into 40, which is 1360. So we're just going to substitute this value of summation x. That's 1360 minus 40k equals to 520. So I'm going to bring this negative 40k over to the other side. So that's going to be 1360 minus 520 is equal to 40k. So this is going to be 840 equals to 40k. Now k will be equal to 840 divided by 40, which gives the final value of k at 21. Alright, now we need to figure out the variance of these 40 values of x. We can see that the information we're given is of minus k, right? And in case of mean, if we were to figure out mean by just summing the values of x minus k, that would be an error. We also need to, if we're subtracting the value of k, we need to add k. And if we were adding the value of k, we would have needed to subtract the value of k in order to figure out the mean. But that's not the case for variance. It doesn't matter whether you're subtracting a certain value or adding a certain value to the actual values of the variables that we're taking into account. So instead of using the formula for summation x and summation x squared, we can easily use the values of summation x minus k and summation x minus k squared in order to achieve the variance. Alright, we know that the formula for variance is summation x squared divided by the total samples minus summation x divided by n squared. So instead of using just the summation of x, we can also use summation x minus k squared divided by the total samples minus summation x minus k divided by the samples squared. Alright, now we just need to substitute the values. The value for summation x minus k squared is 9640 and the value for summation x minus k is 520. So let's just substitute it. That's going to be 9640, and we know that the number of samples is 40 minus summation x minus k is 520 divided by 40 whole squared. So this gives us the variance of 241 minus 13 squared, which gives the final variance of 72. Alright, this concludes the second question. Let's move on to the third one. So for her bedtime drink, Suki has either chocolate, tea, or milk with probabilities 0.45, 0.35, and 0.2 respectively. When she has chocolate, the probability that she has a biscuit is 0.3. When she has tea, the probability that she has a biscuit is 0.6. And when she has milk, she never has a biscuit. So we can see that this is clearly a conditional probability case. And in case of conditional probability, I find it easier if I draw the tree diagram. So I'm going to do that first. And before that, I'm just going to give the notations. So I'm going to denote chocolate with C, tea with T, and then milk with M. Alright, so she can either have chocolate, tea, or milk. So let's just write down the respective probabilities. So chocolate has a probability of 0.45, tea has a probability of 0.35, and milk has a probability of 0.2. And the conditional probability is whether she has a biscuit or not. So that's just going to be B for a biscuit and B dash for no biscuit. Alright, so she can have a biscuit or not, biscuit or not, biscuit or not. Alright, when she has chocolate, the probability that she has a biscuit is 0.3. And if she has a probability of 0.3 of having a biscuit, then her chances of not having a biscuit is just going to be 1 minus 0.3, which is going to be 0.7. In case of tea, the probability that she has a biscuit is 0.6. Similarly, the probability of not having a biscuit will be 1 minus 0.6, which will be 0.4. And when she has milk, she never has a biscuit. So that's just the probability of 0. And the probability of not having a biscuit is going to be 1. Now we need to find the probability that Suki has tea. So that's just probability of tea, given that she does not have a biscuit. So that's the probability of not having a biscuit. And from the Bayes theorem, the probability will be having a tea and not having a biscuit divided by the probability of not having a biscuit. Alright, so we can easily figure out the value for the numerator. So that's just the probability of having tea, which is 0.35, and then not having a biscuit, which is 0.4. So that's just 0.35 into 0.4. Now for the denominator part, that's going to be a bit lengthy because we're considering the probability of not having a biscuit, but we also need to consider each for the case of chocolate, tea, and milk. Let's first look at the chocolate. So the probability of having a chocolate will be 0.45, and then the probability of not having a biscuit will be 0.7. So the first case will be 0.45 into 0.7. That's the case for the biscuit. For the second case, that's going to be of tea, which we already did before. So that's just 0.35 into 0.4 plus the probability for milk. So the chances of her having milk is 0.2, and then the chances of her not having a biscuit while having a milk is going to be 1. So that's just going to be 0.2 into 1. Now the numerator value is going to be 0.14. And the denominator value is going to be 0.655, which gives us the total probability of 0.214. Alright, this concludes the third question. Let's move on to the fourth one. A fair spinner has edges numbered 0, 1, 2, and 2, and another fair spinner has edges numbered -1, 0, and 1. Each spinner is spun. The number on the edge on which a spinner comes to a rest is noted, and then the random variable x is the sum of the numbers for the two spinners. We need to drop the probability distribution table for x. Alright, in order to do so, I'm just going to denote A as the score for a spinner, right? And A has 3 possibilities, so that's either 0, 1, or 2. And then their respective probabilities. Since there is only 1 0 out of 4, that's just going to be 1 by 4. There's only 1 1 out of 4, so that's going to be 1 by 4 as well. But we can see that there are 2 2s, so that's going to be 2 by 4. This is the probability for the first spinner. Now I'm going to denote B as the score for second spinner. And the possible values for B is going to be -1, 0, and 1. And their respective probabilities is going to be 1 by 3 because there's only one -1, right? So that's 1 by 3. Similar for the case of 0, there's only 1 0 out of the 3 values, so that's 1 by 3 as well. And for 1, that's 1 by 3 again because we only have 1 1 out of the 3 values. Now, x is going to be the sum of these scores, so that's going to be A plus B. Right? And we need to drop the possible distributions for A and B. In order to do so, first I'm going to draw probability distribution table for the scores for A and B. Alright, A is going to be on the column side and B is going to be on the row side. So that's going to be 0, 1, 2. That's going to be -1, 0, and 1. So we're looking at the sum of these values. So 0 plus -1, that's going to be a score of -1, and then its probability is just going to be the probability of the first spinner having 0 multiplied by the probability of second spinner having a score of -1. So that's just going to be 1 by 4 into 1 by 3, which will be equal to 1 by 12. Alright, for the second one, that's 0 plus 0. So that's a score of 0, right? And the probability again will be the product of their respective probabilities. So that's just 1 by 4 into 1 by 3, which is again 1 by 12. For the next case, the sum is going to be 0 plus 1, which gives us a score of 1. This also has the probability of 1 by 12 because 1 by 4 into 1 by 3. Alright, that's 1 by 12. Now 1 minus 1, that's the score of 0. This has the probability of 1 by 4 into 1 by 3, which is 1 by 12. For the second case, that's 1 plus 0, which gives us the score of 1. This has the probability of 1 by 4 into 1 by 3, which is again 1 by 12. For the third case, that's going to be 1 plus 1, which gives us the total score of 2. And the probability is again 1 by 12, right? Because 1 by 4 into 1 by 3. Now, 2 plus negative 1, so that's going to be a score of 1. And its probability is going to be 2 by 4 into 1 by 3, which is going to be 2 by 12. For the second case, that's going to be 2 plus 0, which gives us the score of 2, which again has a probability of 2 by 4 into 1 by 3, which is going to be 2 by 12. For the last one, that's going to be 2 plus 1, which gives us the score of 3. Then the required probability is going to be 2 by 4 into 1 by 3, which again is going to be 2 by 12. Now we can just list it as a probability distribution table for x. All right, the possible scores for x is going to be -1, 0, +1, 2, and then 3. So that's -1, 0, 1, 2, and 3. Now let's look at their probabilities. So -1, we only have one -1, so that's just going to be the probability of 1 by 12. For 0, we have 1 by 12 here, 1 by 12 here. So the required probability is going to be the sum of these two probabilities. So that's just 1 by 12 plus 1 by 12, which will be 2 by 12. For the third case, that's the score of 1. It has a probability of 2 by 12, 1 by 12, and again another 1 by 12. So summing these three probabilities, that will be 4 by 12. For the third case, that's a score of 2. It has the probability 2 by 12 and another probability 1 by 12. So the sum of these two probabilities is just going to be 3 by 12. And then the final one is a score of 3, and we have the probability of 2 by 12. Now, in order to figure out if the probability distribution table is correct or not, we can just sum all of these probabilities. And if the sum is 1, then the probability distribution table is correct. Otherwise, you've got a mistake over there. All right, we can see that the probability sums to 1, so this is correct. All right, for the second part of this question, we need to figure out the variance of x. So we know that the variance of x is going to be expectation of x squared minus expectation of x whole squared. All right, let's just look for this value first. That's going to be expectation of x. And expectation of x is just going to be summation of x along with its probability. For the first case, that's going to be -1 into 1 by 12 plus 0 into 2 by 12 plus 1 into 4 by 12 plus 2 into 3 by 12 plus 3 into 2 by 12. This gives us the expectation value of 15 by 12. Now we look for the value of expectation x squared. All right, expectation of x squared is just going to be summation of the values of x squared along with its respective probabilities. So that's going to be -1 squared into 1 by 12 plus 0 squared into 2 by 12 plus 1 squared into 4 by 12 plus 2 squared into 3 by 12 plus 3 squared into 2 by 12. Alright, this gives us the total value of 35 by 12. Now we can just substitute these two values in order to figure out the variance. We have the value for expectation x squared as 35 by 12 minus the value for expectation of x is 15 by 12, which gives us the total variance of 65 by 48. Alright, this concludes the fourth question. Let's move on to the fifth one. Raman and Sanjay are members of a quiz team which has 9 members in total. 2 photographs of the quiz team are to be taken. For the first photograph, the 9 members will stand in a line. How many different arrangements of the 9 members are possible in which Raman will be at the center of the line? Alright, since we already know that there are going to be 9 members, and Raman will be at the center of the line, so that's the 5th position, right? Now we only need to consider the remaining 8 positions. That's just going to be 8 factorial because we do not have any repeating members, right? Because each individual is different. So the number of arrangements in this case will be 8 factorial, which is 40,320. Now for the second part, how many different arrangements of the 9 members are possible in which Raman and Sanjay are not next to each other? Whenever we're looking at a case when there is not next to each other, it is easier to figure it out. After figuring out the number of possible arrangements when the 2 required things or people are next to each other, and subtracting it from the total number of arrangements without any restrictions. So in this case, let's just figure out the total number of arrangements without any restrictions first. So that's going to be number of arrangements without any restrictions. So since this is a case of without any restrictions, we just have to consider the placements for all 9 members. So that's just going to be 9 factorial, which is 362,880. All right, now we need to figure out the number of arrangements with a restriction of Raman and Sanjay being next to each other. So that's going to be number of arrangements with a restriction. And the restriction in this case is going to be Raman and Sanjay are next to each other. Since Raman and Sanjay are next to each other, we're going to consider Raman and Sanjay to be a single entity for now, which means that the total number of members is going to be 8. So that's 8 factorial. But we also need to consider the placement for these 2 people, Raman and Sanjay. Either Raman can come first and then there's going to be Sanjay, or Sanjay is going to come first and there's going to be Raman, right? So that's the total of 2 possibilities. So we need to multiply it with 2. So that's just 8 factorial into 2, which is 80,640. All right, now we will figure out the number of arrangements with restriction. And the restriction here is going to be Raman and Sanjay are not next to each other. Now for this, we can just subtract the number of arrangements with the restriction of Raman and Sanjay being next to each other from the total number of arrangements without any restrictions. So that's going to be 362,880 minus 80,640, which gives the total required number of arrangements at 282,240. For the second photograph, the members will stand in 2 rows with 5 in the back row and 4 in the front row. In how many different ways can the 9 members be divided into a group of 5 and a group of 4? So we just need to figure out the number of ways. Alright, we're talking about dividing the 9 members into 2 different groups. Whenever we're dividing a given set of members into 2 different groups, if we just select the members for the first group, then the remaining members will automatically be selected for the second group, right? Which means that we only need to consider this possible selection for the first group. And we have 2 different groups, a group of 5 and a group of 4. So we can select any one of this to be the first group. I'm going to go with a group of 5 as my first group. So I'm going to select 5 members from the total of 9 members, right? That's just 9C5. And if I already selected the 5 members from the total of 9 members, I only have 4 members remaining, right? And these 4 members are automatically going to be a part of the group of 4. So that's going to be 4C4, or we can completely ignore this second factor and it will not change the answer. So that's going to be the total ways of 126. Alright, this was the case for when a group of 5 is considered to be the first group. But if we were to consider the group of 4 to be the first group, that means that we'd have to select 4 members from the 9 members, right? So that's just 9C4. And if we already selected 4 members, then there are only going to be 5 remaining members, right? And these 5 members will have to be a part of the second group, which is a group of 5. That's 5C5. Or we can completely ignore this second factor and it will not change our answer. So that's just going to be the total of 126 as well. So it does not really matter whether we choose the group of 5 or the group of 4 to be the first group. For a random division into a group of 5 and a group of 4, find the probability that the Raman and Sanjay are in the same group as each other. Alright, so there are 2 possibilities. Either Raman and Sanjay can be in a group of 5 or they can be in a group of 4. So let's just look at the possible ways in which Raman and Sanjay both are in a group of 5. So that's number of ways with Raman and Sanjay in a group of 5. So again, I'll be considering a group of 5 to be the first group. But in this case, we know that Raman and Sanjay are to be in this group. So out of 2 members, those 2 members are definitely in this group. So that's just 2C2. Now the remaining members are 7. And out of these 7 members, we need 5 members in this group. So that's going to be 7C3 because out of the 5 members, 2 are already selected. So this gives us the total number of ways at 35. Now we need to find the number of ways with Raman and Sanjay in a group of 4. So in this case, I'm going to consider the group of 4 to be the first group, right? And out of these 4 members, we know that 2 are going to be Raman and Sanjay. So that's for sure, which means 2 out of those members are selected. Now the remaining members are going to be 7. And we need to select the total members of 4. So that's just going to be 7C2 because 2 out of the 4 members are already selected. So this gives us the total number of ways of 21. Now the total number of ways with Raman and Sanjay in the same group. So that's just the sum of Raman and Sanjay being in a group of 5 and them being in a group of 4. So that's 35 plus 21, which is 56. So that's the total number of ways. But we need to find the probability of them being in the same group. And for the probability, it's always going to be the number of ways with the requirement divided by the total number of ways without any restrictions, right? So here the required probability for the numerator part, that's going to be the number of ways of the required thing. In this case, that's Raman and Sanjay being in the same group. So that's the total of 56 divided by the total number of ways. Now the total number of ways, we already figured that out in the third part of the question and we determined it to be 126. That's the total number of ways of division into 2 different groups, a group of 5 and a group of 4. This gives us the total probability of 0.444. That's going to be our answer. This concludes the 5th question. Let's move on to the 6th one. We're given the weights in kgs of 15 rugby players in the Rebels Club and 15 soccer players in the Sharks Club. Now we need to represent this data by drawing a back-to-back stem and leaf diagram with Rebels on the left-hand side of the diagram. Alright, let's just draw the stem first. So we need to have Rebels on the left-hand side. And we need to have sharks on the right hand side. Now, since we're given data of 2 digits, the first digit is going to be that of the stem and the last digit is going to be the leaf. Let's look at the lowest value for the stem. For rebels, that's going to be 7. And for sharks, that is going to be 6. Let's look at the highest possible value. For rebels, that's 10. For sharks, that's 9. So this means that the value in the stem is going to range from 6 to 10. So that's 6, 7, 8, 9, and 10. Now let's fill up the leaves. So let's look at rebels first. We need the value for 6, but we already determined that the lowest value is starting with the stem of 7. So there are going to be 0 leaves for rebels with the stem of 6. Let's look at the same value for sharks. So that's going to be 6 and 8. Now let's look at the values with the stem of 7. For rebels, that's going to be 5, 8, and 9. That's 5, 8, and 9. And for sharks, that's going to be 1, 2, 4, 5, 5, 6, and 8. So that's 1, 2, 4, 5, 5, 6, and 8. Now let's look at the values with the stem 8. For rebels, that's going to be 0, 2, 2, 3, 4, 5, 6, and 9. So that's 0, 2, 2, 3, 4, 5, 6, and 9. Let's look at the same values for sharks. That's 3, 3, 4, and 5. And 6 as well. So that's 3, 3, 4, 5, and 6. Now let's look at the values with the stem 3 for rebels. That's going to be 3, 5, and 9. So that's 3, 5, and 9. Let's look for the same values for sharks. So that's just going to be 2. Now let's look for the values with the stem of 10 for rebels. That's going to be 2. And for sharks, there are no values with the stem of 10. So this concludes the stem and leaf diagram, but we also need to mention the key. Alright, I'm going to take this as my reference for the key. So that's 3, 9, 2. Now this means 93 kg for rebels and 92 kg for sharks. Now we need to find the median and the interquartile range for the rebels. So let's look for the median first. So median is just second quartile, right? And we're talking about discrete values, which means that the median's position is going to be n plus 1 by 2. Alright, let's look at the number of values. So that's 15. So n is going to be 15. So 15 plus 1, that's just 16. 16 divided by 2, that's just the 8th item, is going to be the median. So let's look at the 8th item for rebels. So that's 1st, 2nd, 3rd, 4th, 5th, 6th, 7th, and 8th. So that's a value of 84. So median is going to be 84 kg. Now, in order to figure out the interquartile range, the formula is just going to be upper quartile minus the lower quartile. So we need to figure out the value for the upper quartile and lower quartile first. So for upper quartile, that's going to be n plus 1 into 3 by 4th item. So we know that the value for n is 15. 15 plus 1, that's 16. 16 into 3 by 4 is going to be 12. So we're looking for the 12th item. So we already determined that this is the 8th item, which means that this is the 9th, 10th, 11th, and this is the 12th item. So this gives us the value for upper quartile as 93 kg. Now let's look for the lower quartile value. So that's going to be n plus 1 into 1 by 4th item. So we know the value of n to be 15. 15 plus 1, that's 16. 16 divided by 4 is going to be 4. So we're looking for the 4th item. That's just going to be right here. So this gives us the value for lower quartile of the rebels at 80 kg. Now, in order to figure out the interquartile range, we can just substitute these values. The upper quartile has the value of 93 and the lower quartile has the value of 80, which gives us the interquartile range of 13 kg. Now for the third part, we're given a box and whisker plot for the sharks. And on the same diagram, we need to draw a box and whisker plot for rebels. We know that the box and whisker consists of 5 informations. So the first one is going to be the lowest value. Let's look for the lowest value of rebels. So that's going to be 75 kgs. Let's mark that value first. So 70 is right here, which means that this will be 75. So that is going to be right here. Now the second information will be that of the lower quartile, and we already figured out that the lower quartile has a value of 80 kg. So let's mark that down as well. So 80 kgs is given right here. Alright, the second information will be that of the median, and the median value we already figured out that's 84 kgs. Let's mark that down as well. Right here is going to be 84. So let's draw it up. All right. Now the fourth information is going to be that of the upper quartile, and upper quartile we figured it out to be 93 kgs. So let's draw that as well. So 93 is going to be right here. Now we just need to find the value for the largest item. That's going to be 102. So 100 is right here, which means that 102 is going to be here. Let's draw it. All right. So this will be the box and whisker plot for the rebels. Now we need to make one comparison between the weights of the players in the Rebels Club and the weights of the players in the Sharks Club. So we can see that the range for Sharks is from 66 to 92, right? But the range for Rebels is from 75 to 102, which means that the average weight for Rebels is going to be higher than that of Sharks. So that's one comparison, right? So let's write that down. This is just going to be the average weight of rebels is higher than the average weight of the sharks. This concludes the 6th question. Let's move on to the 7th one. So the times in minutes that Carly spends each day on social media are normally distributed. Alright, so I'm just going to denote the variable x as the time spent on social media each day by Carly. And we're also given that this is normally distributed with the mean 125 and the standard deviation 24. So that's 24 squared because the second parameter is that of variance. Alright, for the first question, on how many days of the year? So the total days or the total sample is going to be 365. Would you expect Carly to spend more than 142 minutes on social media? For this, we first need to figure out the probability that Carly spends more than 142 minutes on social media. And since we know that X follows a normal distribution, the first step would be to standardize. So that's Z is greater than 142 minus mean value, so that's 125, divided by the standard deviation, that's 24. That's just probability Z is greater than 0.708. Since we completed the step of standardizing, the second one would be to drop the probability distribution. So that's the mean of 0, and we need to find the probability greater than 0.708. So we need to figure out this portion, but in the normal distribution table, we're only given the values lesser than a certain value. Now, if we were to subtract the values for the probability lesser than 0.708 from the total probability value of 1, we would get the required value, right? So that's just going to be 1 minus probability Z is less than 0.708. Now, we'll figure out this value from the normal distribution table. Alright, we're looking at the value of 0.708. Let's look for the first digit first. So that's going to be 0.7. This right here is 0.70. But we also have a third decimal place of 8, right? Which is given in this column. And for the corresponding value, that's going to be 24. So let's figure out the total probability. That's 0.7580 plus 0.0024, which gives us the total probability of 0.7604. Alright, we're going to substitute this value. So we already figured out the probability to be 0.7604, so we're just substituting that. This gives us the final probability of 0.2396. But we're asked about the expected days out of the year in which Carly is to spend more than 142 minutes on social media. So expected number of days. So we know that this probability denotes the expected number of days out of one day, but we're looking at the expected number of days out of 365 days, which means that we're just going to multiply this probability with the total number of sample, that is 365 days, into 0.2396, because this is the probability that gives when Carly is to spend more than 142 minutes on social media each day. This gives the number of days at 87.454. So this can be rounded off to 87 or 88. For the second part, we need to find the probability that Carly spends more than 142 minutes on social media on fewer than 2 of 10 randomly chosen days. So this is going to be a binomial distribution, so I'm going to denote it with another variable y. Now, why is this a binomial distribution? Because we're given a number of samples, right? That's 10. And we're also given probability. So the probability of Carly spending more than 142 minutes on social media, we already figured that out in the first part. That's the probability of 0.2396. Alright, so the parameters is going to be 10 for the number of samples, and the probability is just going to be 0.2396. If this is the probability of Carly spending more than 142 minutes, then the probability of Carly spending less than 142, so that's just 1 minus 0.2396, which is going to be 0.7604. Now, we need the probability that Carly spends more than 142 minutes on social media on fewer than 2 days. So y is less than 2. So that just means y can take the values of 0 or 1. So that's going to be probability y equals to 0 plus probability y equals to 1. Now let's just use the formula for the binomial distribution. That's 10C0 into 0.2396 to the power 0 into 0.7604 to the power 10 plus 10C1 into 0.2396 to the power 1 into 0.7604 to the power 9. Alright, I'm going to write down the probabilities in 4 decimal places. So that's going to be 0.0646 plus 0.2036. This gives us the total probability of 0.2682. If you were to round it off to 3 figures, that would be 0.268. Now for the second part, on 90% of the days, Carly spends more than 3 minutes on social media. So that's going to be x greater than t is going to be 0.90. That's 90%. And we need to figure out the value of t. Alright, what we know is that x follows a normal distribution. So the first step would be to standardize. That's going to be z is greater than t minus the mean, which has the value of 125, divided by the standard deviation, which has a value of 24. This is equal to the probability of 0.90. Alright, now the second step would be to drop the probability distribution. So that's the mean 0. And we're looking at the value at which the probability greater than that value is going to be 0.90, which means that this value of t minus 125 by 24 is going to lie on the left hand side of the mean. That's somewhere right here. So that's t minus 125 by 24. And the probability greater than this, that's going to be 0.90. Alright, now using the symmetricity property, I'm going to drop another probability distribution. So that's 0. If it has the value of t minus 125 by 24 on the left hand side of mean, that means that there's a value 125 minus t divided by 24 on the right hand side, at which the probability less than this value is also going to be equal to 0.90. So we just used the symmetricity property and kind of flipped the probability distribution diagram. So we'll have to look for the probability of 0.90 and figure out the corresponding z value from the normal distribution table. So 0.90 is kind of a standard value which is given in the smaller table at the end of this normal distribution. So that's right here, probability. And the corresponding z value is going to be 1.282. So we're just going to substitute this value. Alright, we figured out the corresponding z value to be 1.282. which means that this value is going to be equal to 1.282. Now we can easily figure out the value for t by the use of this equation, right? So that's going to be 125 minus t by 24 is equals to 1.282. So this just means that 125 minus t is going to be equal to 1.282 into 24. Now t is going to be equal to, so I'm going to move this t to this side. So that's 125 minus 1.282 into 24. This gives us the required t value of 94.2. This concludes the 7th question. And this brings us to the end of this set. If you found this video useful, make sure you hit the like button, make sure to leave a comment below, and make sure you subscribe and hit the bell icon in order to view more of these videos in the future. Thank you.